Why Division 8 is here in this water session? Well, it's because, as you see, we have in our strategic of the division, water as one of the key elements in our nexus elements. So, of course, it's natural that we collaborate directly with the Water Task Force, which is one of the actions we do within UFRO. So we have the divisions for the one that are still not very familiar. And then we have the task force, which are transversal and allow us to cooperate and get more interdisciplinary with other group of interesting people as the one we're going to have today in this session. So this session actually was organized, the thing is not working. It's stuck, sorry. No, unless I do one with the computer, no. Okay, so we are organizing this, as I said, with the UFRO Forest and Water Interactions Task Force. So actually the task force is coordinated by Adam Way, Richard Harper, and Sharon Yu, which I do believe that they are online with us today. And Adam, who is the mastermind behind the organization of this session and behind the task force, is of course with us. And I hope he had the opportunity also to jump in. So this task force has in particular 39 active members in all continents. And the key objectives and activities are to organize conferences and workshops. They organize very interesting and successful webinars as well, develop joint publications, and of course promote research collaborations. So far, they were quite successful in having a special issue in forest ecosystem and management. They published 9 global reviews. Also, they develop a joint paper on emerging topics on forest and water. They organize the 6, they are planning to organize the 6th UFRO International Conference on Forest and Water in Beijing in 2023. And they are planning also an international workshop on forest restoration and hydrological functions in Perth, Australia, in April, next April. Collaborated, of course, with us, with the division, another task force. And in this collaboration with Division 8, also we are going to have for the division a conference next year in between 24 and 27 October in Évora, Portugal. And of course, we are looking forward to see the colleagues from the Task Force on Water coming to share with us knowledge. So we are going then to launch our first presentation of today. Perhaps I will have the other mic you offer today to me. Otherwise, yes, thank you so much. So this is working? Okay. So the first presentation of today, I'm going to invite Professor Irena Creed to the stage. So Irena is an international acclaim, I must say, ecosystem scientist. She works at the Department of Physical and Environmental Science at the University of Toronto. She's a former Canada Research Chair. And actually, he received a number of prizes and recognitions, among them the Fellowship of the Royal Society of Canada and an honorary doctorate of the Agricultural Science at Uppsala University in Sweden. So, Irena, the floor is yours. The technical things work. Right. Sorry about this. Start.
Well, thank you so much, Sandra, and I'm glad that everyone's in the audience here to listen to the Forest and Water session. Today, as Sandra indicated, I'm going to speak about forest water and its contributions to global water security. Tension over freshwater supplies are rising across the planet, and especially in those areas that have transboundary water systems in water-scarce regions of the planet. Nearly 1.8 billion people in 17 countries, or almost a quarter of the world's population, are veering towards a water crisis, with the potential of severe water shortages anticipated in the next few years. Of the 17 nations, most are in Asia, including India and Pakistan, Africa, and the Middle East. In India, just as one example, the government says that by 2025, water availability per person will decline significantly and lead to a water-stressed condition across the country. Forests are key to the provision of the world's freshwater resources. In the scientific community, our focus has been on upstream, downstream, surface water and groundwater connections. But as our Global Forest Expert Panel report has shown, that we need to also extend that focus to upwind, downwind teleconnections. Specifically, forests transmit water to the atmosphere as vapor, which then turn to the land surface as precipitation, often outside and far away from the basin's boundaries. This satellite footage shows the forests of the Amazon basin and the Congo basin transmitting water vapor into the atmosphere, forming these atmospheric rivers that can transport water over very long distances. Now, large-scale forestation efforts are altering the global water cycle. And these alterations can be exacerbating or alleviating the pressures on freshwater supplies. Forestation includes both deforestation, reforestation, and afforestation. And collectively, these forestation efforts are redistributing the abundance of forests on the planet. In this Global Forest Resource Assessment from 2020, you can see predominantly in South America and Africa, a loss of forests, whereas in Asia, Oceania, and Europe, a gain of forests. These forestation efforts are also shifting the type of forests with a shift from naturally regenerating forests to planted ones, and the dominance of introduced species in the planted forests, at least in some regions. You can see here that in Africa, most of these are introduced species, as well as in Europe, but not so much in North and Central America. Overall, across the planet, you can see that it's predominantly not native species that are being planted. Now, the shift from these complex or more diverse forests to simple monoculture forests will have fundamental consequences on water fluxes. And in our recent paper, we put a spotlight on the risk of the homogenization of the terrestrial water cycle, which means a narrowing of the distribution of these water fluxes due to forestation efforts, and that this could lead to lower resistance of forests to changing climate conditions. Now, worldwide, policies are being designed to increase the land's ability to sequester carbon. We know that forests cover about 30% of the planet's land surface, with most of these, 50% of these, in only 5 countries. But as we were talking about yesterday, the planet's land surface can naturally support 4.4 billion hectares of forests, meaning there's an additional 0.9 billion hectares where new forests can grow. Clearly, we had some criticisms of this paper yesterday because it didn't include the people in their estimation of the additional forest. But today, I just want to give you a hypothetical scenario that if we were to plant these, what the consequences would be. So on the carbon side, we see these new forests could pull 206 gigacarbon of CO2 out from the atmosphere, but they would also affect the global water cycle. In this very recent paper, the authors consider the consequence of this global forest restoration for carbon on water. On the left side, we see model predictions of evaporation of water to the atmosphere as vapor. And on the right, we see the model predictions of recycled evaporation falling back to the land surface as precipitation, assuming we use the full forest restoration potential. The authors go on to show the implications of the recycled evaporation on regional water availability. On the left, the model shows the water availability without the recycled evaporation, and on the right, with the recycled evaporation. So what does this mean for water scarce areas of the world? This map shows the regions facing water scarcity for at least 9 months of year in these bold hatched areas. And what we can see is that the restored forests can alleviate water scarcity in some areas, but they can amplify water scarcity in other areas. How can this science be used to reduce the risk of water scarcity? Previous speakers have spoken about the need for work at the science policy interface. I want to extend this bridging activity to include the science diplomacy interface. We know that water science informs actions, but water intelligence informs the actors. And in our work with diplomats, they make it clear that greater water intelligence on the importance of forests and water supplies is needed to inform diplomatic processes. Diplomats have different tracks that they can use to address water conflicts. These tracks are formal, such as track 1, or informal, such as track 2 and 3. These tracks are traditional, from government to government, nation state to nation state, which is track 1, or non-traditional, which would be government to government, but including the subnational entities and experts, such as track 2, but also people-to-people engagement, such as track 3. What is often missing or inadequate is what we call track 4 diplomacy, where governments create mechanisms for the inclusion of track 1, 2, and 3 diplomatic activities, and in particular, bring the voices of the people to the decision-making table. Here we show this plot of what the dominant drivers of water conflicts are, which are of high importance and high uncertainty. Speaking to leaders across the planet, they identified the geopolitics, whether the context is one of a cooperative arrangement or a conflictual one, as well as the human capacity to affect positive change, being really strong or weak. We engaged leaders from these 4 case studies who enabled us to place these conflicts on this plot. Interestingly, our 4 case studies covered the range from high cooperation and high capacity to affect positive change, to high conflict and low capacity to affect positive change. In the next few slides, I will go briefly through each case study. In Israel and Palestine, the water issue is freshwater scarcity. Israel controls access to the majority of water issues. There's a moderately weak human capacity to change because of that gridlocked conflict. And the intergovernmental interaction is also conflictual. There is basically only track 1 type of diplomacy with the Joint Water Committee, but it's largely been declared dysfunctional because of that power asymmetry that exists between Israel and Palestine. In India and Pakistan, water issue is droughts and floods. Here we found that the human capacity to affect positive change was moderately strong, the intergovernmental interaction moderately cooperative, but their diplomatic tools rely on the Indus Water Treaty. Now, many people view this as an astonishing treaty that brought together India and Pakistan. We view this as politically based, not science-based, and we wonder about its resilience moving into the future. Iran and the Gulf Cooperation Council. Here, there is no water, no fresh water. They rely on seawater and the desalinization of it. Their human capacity is moderately weak, strong science and technology, but very weak civic society. Their intergovernmental interaction is moderately cooperative. You have multinational agreements, and when really bad things happen, they come together and work in a cooperative way. Their diplomatic tool is, again, only focused on track 1, a science-based Gulf Cooperation Council. And finally, in the United States and Canada, where we focus on the Red River Basin, here again, still facing similar issues of droughts and floods. The human capacity to affect change is strong. The intergovernmental interaction is cooperative. And here we see that multi-track approach. Track 1, science diplomacy through the International Joint Commission. Track 2, top-down cooperation with local stakeholders. Track 3, bottom-up engagement of local stakeholder engagement. And track 4, but arguably still weak. We still have a distance to go. Local stakeholders are providing feedback, but they're not influencing the decisions. So bringing this back to forest water, changes in the forest water flows can exacerbate or alleviate these water supplies. And so they are like a lever in terms of the conflicts that are happening. However, to date, there is no intergovernmental institution that is tracking this. There is no human capacity to affect positive change, largely because people are unaware of it due to a lack of that water intelligence within diplomatic circles. So finally, this talk is really leading to a call for action. We would like to propose a multilateral institution, Track 1, that engages in forest water science diplomacy and advises national governments. This institution would work closely with decentralized regional water agencies, Track 2, that track changes to the forest water flows both from the originating source and to the region that it is delivered to, as well as engaging local stakeholders to develop a shared understanding of forest water. That's Track 3. Now, these regional water agencies could then report back to the centralized multilateral institution that synthesizes the data and engages in top-down water diplomacy on an international effort to affect that positive change and really bring forth that Track 4 diplomacy. Now, we presented these ideas just recently at the BLED Strategic Forum. And I wanted to say that we were able to get this resolution passed, and this has been endorsed by the Deputy Minister and Foreign Affairs Minister of Slovenia, where BLED is held. And basically, we're looking for how water and peace should come together. A concern is that the United Nations Conference on Water does not want to deal with issues of peace. And we're asking for people to make the call and to lobby that it be included. So we therefore call upon the Kingdom of the Netherlands, Republic of Tajikistan, and the United Nations as co-hosts of the UN Water Conference to acknowledge the interconnections and interdependencies of the global water system and the fact that actions in one place will have consequences in others. The other ones you can read on the screen, but I just thank you for your time and listening to this. Thank you, Sandra.
Thank you, Irena, for this amazing talk to start this fantastic panel we have today. So I'm going to ask all of you to hold your questions because I'm sure you have quite a lot, but we plan to do the questions and the discussion at the end of this first panel. So hold it there, write your questions, and we go to the second panel presenter today, who is Silvio Ferraz, who is at the University of Sao Paulo, Brazil, and he's going to bring us to restoration in tropical forests. So Silvio, the floor is yours.
Okay, thank you for attending this talk. And after this wonderful overview of what's happening in the world, maybe I will have a kind of zoom in Atlantic forest in Brazil. So is this button here? Where? Here? Okay, so when you think about restoration, we have this dream to restore the original ecosystem. But what happens frequently, that is not possible. So you reach some different state, not so good as the original one. And when you see what happens with ecosystem, when you have the kind of degradation, we are losing different ecosystem services along time. But when you try to restore, many times we decide or we focus on just one of those services. For example, in Atlantic forest is very known because of its biodiversity. So many projects are focused on biodiversity. But recently we are focusing on carbon, for example, in Amazon. So we're just focusing on one service. Then many times we have some consequences on water when you focus on one just service. So in this talk, I will just focus on water yield and water regulation. That is very important for the region where you are in south of East Brazil. And where you have this nice forest, is the Atlantic forest that is very known because of its biodiversity. It's a hotspot of biodiversity. And then when you heard about Atlantic forest, you imagine this very nice forest, very dense and very humid. But in fact, this biome is very diverse because we have a different kind of vegetation on this biome. And this dense forest, this very humid forest is just present in the coast. So we don't know exactly how you be the response of this different kind of vegetation to when you try to restore them. This vegetation was gone since the 1500s by the colonization and centuries of agriculture. So now we have many efforts to restore this forest, this biome. The quick question I'd like to address today is how water use and the regulation would interact over the forest restoration process in Atlantic forest biome, and how balanced this service throughout forest management. And to do that, we use many data we have from different catchments, including forest plantation, pasture, and native forest. And also have some data from field work, including sap flow measurements, filtration, stream flow, and also stand flow. So we model the change, land use change in Atlantic forest using a remote sensing hydrological model and sampling different regions of this biome. And the results we found, there are many different results, but I just should focus on just one here. Comparing, for example, the evergreen forest, that is a very dense and humid forest. When you restore this area, you have not so many difference in hydrological responsiveness. But if you take a look in a semi-deciduous region, like in the interior of Brazil, there's a huge difference when you put forest there. So this area is very populated and it's a very used for agriculture for many years. So you expect to have a very good, very high impact when you change land use in this region. And this could be better seen when you put in this dryness gradient. So this semi-deciduous forest is located in this subhumid region where you have this trade-off. We expect this trade-off when you have a pasture and you put forest there. And we have some data also for water use. Here, for example, in plantations, in this region, we are using almost 95% and sometimes 100% of the water available. So plantations, like a very intensive plantation in this region, is not a good idea because we have problems. And it's not so much when you have this natural forest that use 80%, 85%. So this little difference, 85% to 95%, make all difference for water availability to people. And the water problem is the diversity, because Atlantic forest is a high diversity region. So we have trees with different phenology, different height, different canopy, different species, different age. And when you put this plantation, very homogeneous plantation, Irena said about the homogenization. So this is a very problem in this region also. And we found also the plantation effect measuring eucalyptus, but we don't know if you have the same effect with natural species plantation on restoration. We expect to have this same effect on this. And we found some difference in water use, for example, in different species. The same location, they use water in different patterns, or the same species in a different location in a small gradient. We have a different also transpiration because they have different access to water table. So it's expected in regions like in Brazil, where you have this very fast growth of forest, time gap between forest structure and function. When you can have to restore the structure, but the function, you take more time to be restored. So most of the restored areas in Brazil, we are facing this function debit. So we don't know how much time you take to have this again. And this is more evident, for example, in soil infiltration for water regulation. Here, we found that it took 20 years in this region to reach the same level of water conductivity as a reference forest. And looking to the canopy and the soil infiltration together, we see that in this region, we have a very fast growing of canopy using water and putting water in the atmosphere, but the soil infiltration takes more time. So we have this trade-off in the middle of this process. So how we could reduce this trade-off by management? So in many regions of restored areas in Brazil, or in Atlantic forest, we found different pathways. For example, starting for degraded pasture, we can have a degraded forest that is worse for water because it uses much water and you don't have the effects on soil. And then we can have this kind of a secondary forest, not so good for water, but it's okay. But we are trying to reach the same level of conserved water, conserved forest that has lower water use and good benefits for soil. So how we can drive the secondary forest to the restoration to reach this target, we don't know exactly. So we have to take an attention the results we're taking for Lost Plateau because many, besides the different climate, many of they are finding there could apply for regions like Brazil in the same deciduous forest because they have different patterns of use for water in different species, different patterns or different thresholds for land cover and different response for evapotranspiration regarding tree density, and also facing some problems where they put forest in regions where originally they don't have forest. So forest restoration is a complex because we know that water yield and regulation is most driven by physical characteristics, but we have to find ways to control evapotranspiration in these projects, maybe reducing forest growth or reducing leaf area, or maybe thinning or using mosaic. We have many options to do that. And also we can improve the water regulation in soil, changing the way we prepare soil, we plant, maybe putting more organic matter on the soil. We don't know, we have to think about many other possibilities to have these successful projects on water for restoration. And we have to consider that there is some changes in the temperature and rainfall, and also the soil was changed a lot in hundreds of use for agriculture. So it's impossible to reach the same ecosystem we had in the past. We have to face this new reality. So my final remark is that subtropical areas subject to water limitation, like we have in Atlantic forest, present different response to forest restoration. So new forests would provide different hydrological service from the primary ones. And water yield and regulation of new forests could depend on a specific management. Forest projects seeking water yield or regulation at these regions should focus on the combined hydrological response with other services. We're not possible to focus just in one target. And you already know how to do that. We should just apply the knowledge we already have to manage those forests seeking to reach those objectives. Okay, thank you.
Silvio, for this trip to the tropical forest and the problems. So it's quite nice because as you see, we have a very diverse panel that come here with really different realities and different stories. So now we're welcome Lars Hogbom. I'm sure I pronounced very bad his name, but anyway, okay, good. So he's from the Forestry Research Institute of Sweden and the Sweden University of Agricultural Science. So welcome and thank you for being with us today. So the floor is yours.
Thank you, Sandra. I will spend around the coming 8 or 10 minutes on various aspects of forests and forestry, and how we can use trees, woodlands, forests to give our waters a helping hand. Just to make it short. But I would like to start the scale issue, because this is one of the problems we have. I mean, we can measure everything with precision in that little droplet. We know everything. But how relevant is that for the landscape scale? And how do we go from one scale to another? And going to this landscape scale, all other aspects comes in as well. I mean, humans, people, humans and animals. Sorry. And forest and water, they're having a codependency. What happens to the forest affects the water and vice versa. So we have to treat our water with care. And for those of you who were on the excursion on Wednesday, you already heard that story. I mean, drinking water from forests are usually of high quality and can be used directly for consumption. And this concept has been used throughout the world, not only in Austria and Vienna. This example is from Padua in Italy, but there are huge examples all over the world. In New York City, Copenhagen, there are many cities that actually use woodlands and forest for water protection. And we don't want to see signs like this, water not drinkable. I mean, we want our water to be drinkable. That's important. Another problem we are facing is diffuse pollution from agriculture. I mean, in Europe, only 40% of our surface waters reach good ecological status. And diffuse pollution from agriculture is the main source for this. So planting trees along rivers and other water courses could be a solution to this. And we actually had a cost action ended a few years ago, and here's the guideline how to do it. And it's available in several languages, including German, Hungarian, Polish, Slovak, Spanish, and Ukraine. And it can be downloaded from Forest Research homepage. Or you can ask me later, I can give you the links. So now you have to excuse me. Now going back to the north, the home of Norway spruce and Scots pine. And this is a picture, random picture somewhere in the landscape. It's rather flat. It's dominated by peatlands and forests and open water. And that's about it, you might think, but sorry. This landscape has been used for centuries for a lot of things like charcoal production, tar production, forest grazing, swidden farming, and so on. And also some cut and run forestry in the late 19th century. So in a sense, it's restored from that stage through forest management. And if you drive through the landscape, you can see the abundance of water and trees. It's not many people up there, but they're probably somewhere in that picture. And the waters of this boreal landscape came in different forms. I mean, small rivers with scenic beauties and open wetlands and small creeks and even smaller creeks and mosquito-infested woodlands, wetlands. So we got it all, and we need to take care of it. And we also have these riparian zones that we are caring about. I mean, the riparian zone is the zone closest to water, which is where the water quality is more or less formed. And there's also an important part of connecting the land with water, and it's also important for this connectivity of the landscape. So it's an important part that we need to focus on. And we also do a lot of forest operations. Sweden alone, I think, we fell about 180,000 hectares annually. And the effects of water has been skillfully summarized into a paper in this task force special issue of forest ecology and management. So you can look that up if you're interested. And one thing that comes more and more into play is this depth of groundwater maps. This is just somewhere in Sweden, based on a LiDAR scanning and a digital terrain map. We're able to model depth to groundwater. The light blue thing is actually open water, and the dark blue is shallow groundwater. It's above 20 centimeters the surface. And you can actually use that information when planning logging, so you can avoid those wet patches. And it's used daily in logging operations. But sometimes things go pear-shaped anyhow. And you can change the hydrology, you can cause ruts, starts erosion, shortcut hydrology, so on and so forth. And you can actually avoid this by better planning and use some technical tools like brush mats, just to drive on them instead of taking them out. That reduce rutting, or use temporary bridges, or wider tracks with a larger bearing capacity, or more wheels. And if you're sharp tie, you can actually see there's a wooden bridge underneath the bogey of that forewater. So that brings me to the next part of this. It's about knowledge transfer. I mean, we know a lot of things. All of you know a lot of things, but how do we transfer that knowledge to the general public or to the people, the end users? So this is one example. It's an excursion or one-day training course with forest operators. And there is actually 3 women in that picture, if you look closely. So they're actually here as well. Another way is to use instruction films. We actually have one out on YouTube, which is quite good. Got a gold medal at the World Media Festival in Hamburg. So it's brilliant. But also, how do we communicate with decision makers? we need the same message to go through to all groups, but we have to pack it differently. So what is the next step? I think we need to integrate everything. We are still doing too much research in silos and not communicating with each other. So we need to bring together biodiversity aspects, hydrology aspects, carbon, and so on. To go further. And I would like to end with some questions. I mean, what do we want? I think we need to define what we want before we start doing some work, and which way to go. That road sign is actually genuine. Or are we just going around in circles, reinventing the wheel all the time? And the older I get, I think that reading through modern literature is more or less the same as was written in the 1940s, 50s, sometimes. I think we need to discuss that in the broader scale. So thank you for attention.
Thank you, Lars.
And for those of you who are interested, this is just a summary of these papers from the last 2 or 3 years. But if you're interested, I can give you a copy.
Thank you again, and thank you for this. We were jumping from tropical forest in Brazil all the way to boreal forest in Sweden. And I think we're going to go back to your slide when we get into the panel discussion in just a few minutes. But before, let's go to our last panelist before we go into the discussion and exchange. So now we have Lulu Zhang, that she leads a research group at the United Nations University of Danish University from Dresden, right?
Yes.
Okay. Thank you for being with us today and for sharing. So now the floor is yours.
Thank you very much, Sandra, for the very nice introduction, and also welcome to our session. Today, I think I'm going to talk a little bit about how to integrate all the evidence actually for more coherent policy making, which I will particularly actually focus on the perspective on managing the soil, forest, water, climate in action. Before I start, I also want to acknowledge the other expert involved in this work, and that is Dr. Kashfetzer and Professor Kai Harsfiger, and also Professor Yan Hui Wang from the Chinese Academy of Forestry. Okay. Yeah. Okay. Yeah. 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 And perfect. I think I don't need to spend more words to emphasize actually the fact that actually forests receive more attention than ever, and as a nature-based solution for more sustainable development. And also the keynote speaker and also the session on forest degradation and restoration yesterday, I think they provide a very comprehensive overview of this United Nations and also global initiative, which put focus on a forestry because they consider forestry kind of as a cost-effective measure to solve almost all problem we face. But I hope that we could also agree to say that the expectation on forests is really high, but it's rather unrealistic to realize all these goals equally. I think the rationale behind all this initiative is rather clear, because I mean, forest can provide us a multi-purpose or multi-functions that could provide a range or a number of ecosystem services that's our humanity relies on. And such kind of ecosystem service and function, they are closely related or indirectly also related to the SDGs. And since this session is about actually forest and water, I'm going to talk about a project actually that has been completed a while ago, but I will try to synthesize some key evidence that why we need to integrate such kind of interaction or kind of nexus perspective in terms of forest and water. And I'm going to talk about the project that we have done on the List Plateau. And List Plateau, probably one of the few regions, actually the afforestation or forestation has been implemented for decades already. And also that's why the impact of such kind of forestation is rather visible. And there are very positive ones. For example, the Yellow River sediment load has been reduced by almost 90% over the decades. But of course, there are also some unexpected impact, which you might know or familiar with this phenomenon that actually after this large scale forestation program that implemented on the List Plateau, and there's also kind of a visible river discharge reduction over the years. And here you can see a figure that actually all the major tributary gauging stations along the Yellow River. And the Yellow River is also the second largest river in China, which is a major surface water source for the northern China. So I think there's, since this phenomenon has been observed, and there's a large number of domestic and also international scholars, they try to investigate this issue. I think the major methodology applied so far is about meta-analysis and also comparative watershed study. And there's also a common kind of agreement, or as a kind of a widely accepted conclusion, that actually the forestation takes the major responsibility for such kind of water decline. And while the climate change, of course, also play a role, but rather a minor role. Despite such kind of agreement, but there's not much actually process-based knowledge or kind of evidence to show how exactly such kind of forestation really changed the water cycle and also the water fluxes. And this is exactly the point why we came actually into this area and also study our project, because we want to exactly to investigate the interaction between the forest, soil, water, as well as the climate. And I will not talk about too much details about the methodology applied, but generally we combine the bottom-up and top-down approach. Here I will much more focus on kind of a bottom-up approach that we want to close the whole water cycle and also to construct the water budget. And therefore we measure the whole water balance, as well as we also sampled the soil and different land uses. As you can see that we use all different equipment and also the measurement, try to measure every water budget component. For example, there's transpiration, there's also soil evaporation, there's also soil water, and try to capture all the water budget component. And the study site we choose actually is a very typical forestation site on the List Plateau, which is kind of located at a kind of a semi-humid to semi-arid transitional area, and the long-term average precipitation is about 510 millimeter, and the average temperature is 10.2, and the plantation is only a slightly more than 30 years old. And why we choose actually this? Because we choose the natural grassland as kind of a represent the minimum water use of the land use on the List Plateau. Why And then the black locust plantation forest with the end story will represent the maximum water use. And in that way, we could really understand, okay, how the water fluxes have been changed. And here also some pictures about, okay, the step flow measurement, about the freeland precipitation through for precipitation, and also the lithometer we installed. And here also some picture about the soil profile and different land use. So in the next slide, I'm going to present some key result only. Okay, I think you see this picture today for the second time already. I think in the previous presentation also showed. So we could calculate actually the annual budget of the black locust plantation forest. And it's very interesting to notice actually the evapotranspiration of the plantation forest account for 92% of the annual precipitation, while under the grassland is only 80%. And more interesting to notice actually is the end story of the plantation forest has a higher water consumption than the over story, which actually is quite a kind of unexpected result for us. And this also leaving that only 8% and the forest, the seepage, while the seepage and the natural grasslands is 20% the annual precipitation. But I also want to draw your attention that actually the experimental observation that we done, actually the annual precipitation is 700 millimeter. It's really wet. If you remember, I mentioned before that the long-term average is only 510. And if it's an extremely wet year, you can only have 8% deep seepage, that you can expect that in the normal or even dry year, that probably no seepage at all under the plantation forest. And this, of course, can also be verified under the soil water monitoring and the both grassland, the natural grassland, and also the plantation forest. If you look at actually in the shallow soil, there's only periodical actually water shortage. Sorry, I forgot to mention here we use the soil pressure head as the indicator. That means the higher the value, the drier the soil. So you can see in the shallow soil, there's only periodic dry period, which mainly happens during the growing season. But if you look at actually the deeper soil, you will see under the grasslands, the water content is always good, actually over the whole time period. Why under the forest, there's always a high soil pressure head. And of course, this also verified our assumption that if there's any seepage, probably can only happen during the non-growing season. That means during the winter period. And if we further look into the details about the soil retention curve, at first sight, I think you will feel probably there's not much difference between the grassland and also the forest. But I think the difference exists actually in the plant available water availability, which means between the range of the PF 2.5 and also the waiting point. That's between the field capacity and the waiting point. And so you can see there's definitely more water available, plant water available under the forest than the grassland. But that's interesting, as we know that actually that means the deforestation promotes the formation of the mesopore, but not the macropores. So what could be the reason? Because it's quite contradictory to what we expected. I think probably the most possible explanation is that, as we can see, the deeper soil and the forest actually will have a very intense dry and wet cycle. That's why actually the macropores and the forest are rather stable, they turn to collapse. Last but not least, if we look at the soil organic carbon and the natural grassland and also the forestation, and the soil organic carbon is relatively low because that's after 30 years of forest land is only has a slightly higher content than the natural grassland. And this also gives us actually another indication that if we want to use forest as a carbon sink or carbon pool, we probably need to really have to do more action to stimulate the soil organic carbon, to enhance the soil organic carbon and the forest soil. And also, as we know, actually, there's also payment for forestation has been implemented on the Les Plateau. Because the rural household or the farmers, they are paid to convert their degraded farmland to forest. And such kind of conversion can be paid up to 8 years. And the participant can get cash payment for internal green and livelihood and seedling. And current, the money they could get is about $600 US in total. And these standards has been applied over the whole Les Plateau area. And most farmers, they very support this action because they could receive some economic benefit. But however, there are also some weakness in this payment scheme because this payment stop after maximum 8 years. That means they could suffer economic loss after 8 years. And also the payment only for planted trees, but not for any management. And also farmers, even they want to manage the forest and they have no knowledge, which is also cause it's rather unmanaged the plantation forest, which use a lot of water. And I will come shortly to my summary. That means the forestation has enters the water cycle, means changes the green and water fluxes, and result in a trade-off in water supply services. And forest management is really a key to minimize this trade-off, to really reduce the water consumption and also promote the water yield. And payment scheme is definitely need to be revised, and particularly to increase the perspective to encourage or motivate the local farmer to do forest management, and also stimulate soil carbon sequestration potential is very key if we want to promote forest as a carbon pool. And forest development definitely required to integrate such kind of resource necessary perspective, because if we manage the forest, so we generally change all the process of the environmental resources flow. And last not least, but as I can show that comprehensive evaluation of interactions among the forest, climate, soil, and water could help to consolidate knowledge and translate the evidence into policy, coherent policy relevant advice. Thank you very much. Yeah.
Thank you, Lulu. So now we have actually 10 minutes to be able to exchange and discuss of these fantastic panelists we have today. Before we go into the questions and see also if we have questions on Zoom, I'm just going to steal one of the questions that Lars have that I like it very, very much. Here we have very different perspective for like study cases for problems at the country level, but also a very nice global perspectives. So for that, we know that we have increasing problem of water, as it was quite nicely presented, the problems with drought and floods. So going back to one of these key questions, I like it very much. Are we going in circles in the search for solutions? Because this is the question, I mean, which solutions we have there? Well, of course, we have climate change between, but also I like it the way Irena presented quite nicely the issue of conflicts and human capacity to affect change. So I will go back to my panelists first before going to you guys. In terms of reflecting, are we going in circles? Do you see any concrete ways forward it's not an easy question, to really tackle the issue of conflicts and water. So perhaps, Irena, that you came with a very, very nice summary of all that.
Well, thank you so much. Is this on? Can you hear me?
Not really.
So thank you for the question.
And you can hear well. Sorry. Yes. Okay.
I think the answer I would give you is actually a very simple one, and that we need to break down the barriers between the silos that we exist in. Over this past year, I've been working very closely with something called the Global Diplomacy Lab in Berlin. And it was astonishing to me, and I could just see the diplomats in the room, eyes get so excited when they could see that map of the atmospheric rivers, or knowledge that's communicated in a way that's simple, that they can understand. And they're open and almost starving for that kind of water intelligence. And so I think that was an incredible lesson to be learned, that it's not good enough just to do our science. We need to take that extra step, whether it's science to policy or science to diplomacy, and bring them into that kind of understanding. And I know that Lars talked a lot about the communication and has done a fantastic award-winning movies on trying to communicate that as well. So right now we jokingly call that we needed a water intelligence agency that would basically share that knowledge to the broadest number of stakeholders as possible. And that's something, an idea that we would hope that the largest community will start to embrace.
Thank you, Irena. Silvio, perhaps a vision of how things are in Brazil or in Latin America in a wider perspective. How you see this from your perspective?
I don't know. Maybe, yeah. I think we were waiting for the water time, because first in Brazil we have the biodiversity time. Now we have the carbon time. When you have the water time, I don't know. We're waiting for. So it's missing this broad perspective, all service together. We don't have that. I don't know. Maybe it's a problem.
It's not a call to action yet, as it was. So it's still waiting. Lars, you want to add something in terms? It's your question, so you can answer to your own question.
In a sense, I think we're going around in circles because we try to repeat things that we have done before, and we don't bring it any further. I mean, and by further, I mean, we are still, water people are doing water research, foresters are doing forest research, and biodiversity people are doing biodiversity results. But how do we put that together in a broader context? And also, like Silvio said, I mean, we need to think multilateral here in various dimensions at the same time. And I think that's the problem, because at least my brain is just two-dimensional. And how do you convert that two-dimensional or three-dimensional thinking to a multi-dimensional thinking? And also, I mean, if you go to Brazil and you come up with solutions how to do it, how does that apply for the boreal zone or vice versa? I mean, one solution doesn't fit all. I think that's also an important lesson that we need to.
Yeah, it's never easy to translocate in scales or different realities, that this is part of the problem.
Yeah, and politicians and decision makers want easy answers that can put on some nice pamphlets and say, let's do it like this. And it works in places, but in other places it's just bollocks.
Thank you for this realities. Yeah, perhaps it's also to be more holistic, to go, well, like the first slide I put, which is the vision from Division 8, that is in the Nexus approach, and how we can really find the interlinkage in order to go to solutions. That is just, of course, an approach. Lulu, you had perhaps some thoughts on that.
Yeah, actually, I think a key issue actually under the changing climate is really about how to balance and prioritize actually the function and the services that match actually to meet to put into the local context and also for the regional development, because different regions face different problems and there need specific approach or adaptation measures at the local scale. And then that means we definitely need to understand what is the priority and what the local peoples need. And that also need we collaborate across different disciplines. I think interdisciplinary or transdisciplinary collaboration is very key to develop a very successful solutions that can be accepted and also implemented at a local scale. That's why I think to thinking beyond your own area and to learn from each other and to co-develop the solutions that can be accepted. Of course, sometimes it's inevitable to make some compromises, but at least such kind of solution can be implemented or applied in the place that can have co-benefit or at least to make it better. Yeah.
Okay, thank you. Yeah, I think it's the issue of how to find global solutions with the climate change, especially with water, where some are, to drought and floods, and the others are going towards desertification. So the issue is, how you can find global solutions, such a different problems and different challenge. So now I would like to go to the question we have. Do we have questions in Zoom, Kevin? Yeah, actually, Adam, you are there because it will be nice to have some word from you. You don't know if you can hear us. Oh, brilliant.
Yes.
Oh, nice to see you. He is the person who organized this session, so big thank to Adam for that.
Thank you. The panel talk are excellent, and I learned a lot. And I think just based on some questions raised in the chat box, I think Giesen asked a question about the hydrological response, and there are larger variations in hydrological response to global forestation or restoration. So there's different kind of responses. And so I think the critical question to us, like everywhere is different, right? As Lars and many case study like from panel talk indicate, I think the critical question I got is like, how can we implement the forest-water relationship if we really want to protect the water through forest management. But everywhere is different. So I think that's kind of a quick question. And we like to have some idea from the panel, just to get some perspective or share your experience. How can we do something on the ground? Or maybe change the policy, as Irena mentioned, because of teleconnections across the watershed or across the regions. I wonder if we get a quick response from the panel about what should we do? How can we move forward in practice?
Somebody want to answer to this? Yes.
Well, thank you, Adam. I think the way forward is to be humble, just to realize that things are different. And coming from the northern Sweden, where we have probably one of the more resilient forest ecosystems in the world, and apply that for the rest of the world, it's no good, but it's simple. And so I think we need to learn more how to communicate between different parts of the world to come up with the right solution for the right place. And simply talk to each other.
A final thought before we pass to the questions?
Just to reiterate and emphasize what Lars just said, we're really smart. We have a lot of amazing data. The data is fragmented, it's siloed. What we can do is start building cooperative synthetic work and to work more closely with the field scientists, with the policymakers and the data modelers, with artificial intelligence, machine learning. It is complicated, but we can still make progress in that area if we come together as a community. I wish UFRO could lead this. I think that given it's a volunteer organization, we need resources. So we need nation states to come together and dedicate resources to this important work to enable us to move forward. But I wouldn't be hopeless, Adam. I think we have to remain hopeful that because we have that intelligence, we can make a difference.
That's very good. Thank you. I can take a couple of questions there. Yes, have one there, if, and the other in the back. So, yeah, there's a mic there. Somebody with a mic that can go. Okay, you can pass.
Hello, I'm Maíra. I'm from Brazil. I would like to ask for Silvio. Silvio was my professor at the University of São Paulo. It's really nice to see you here. In Brazil, the forest code or the restoration law is really related to water. So when we sell projects for landowners, we are saying today that the water not will come back, but the reforestation will help that. So my question is, I love the representation. I think you should really divulgate that for people who are working on the ground, because today we have different kinds of challenges. For example, a lot of targets to restoration, like 12 million hectares in Brazil for the Boom Challenge. And normally the NGOs has 2 or 3 years for implementation. So it's really short time to cover an area. In Brazil, in Atlantic Forest, we have a problem with brachiaria. So the objective of the NGO is to cover the forest fast as possible to decrease the cost of restoration that is really high when we say about planting. So my question is, what are your ideas about this cost of restoration and water ecosystem service? And if you plan to divulgate this data to policymakers or NGOs who are working on the ground, because it's a really important message. Thank you.
Silvio?
Oh, people don't like to hear me when I talk about this, because there are many efforts to put forest on the ground, and I would say that you have to take care, because maybe forest could cause problems. So it's difficult. It's a communication issue. So the message, as I think Lars said, it's complex. It's not so simple. There is no simple solution. That put forest everywhere, that will be good. So we have to think, to have to plan, we have to see the local problems. So we need we're smart. We know we can do that. We have knowledge to do that, but it's not simple. So in Brazil, we are having this kind of simple solution. So let's put forest. It's good because we're interested in biodiversity. So, but it's not so simple. It's complex. There are other services that could take in account. So it's an issue there, the communication problem.
Thank you, Silvia. So I take one more question there and another there, and then we need to go to the second block. So please try to be short and sharp with your question. Thank you.
Thank you. I'm Jesse from Kenya. My question is to Lars. I like the option of talking to each other, but the question was, where was the industry in that discussion, the people making the trucks, the big machinery in solving that? And then find what was the uptake from the operators and the people working in the forest to those discussions that you showed?
Lars.
Yeah, well, actually, I spent the last 10 years traveling around Sweden and having field courses for machine operators and forest managers. And at least in Sweden, the people are very interested in learning more about reducing damages to soil. I mean, there are hunting grounds they're driving on, and there's their berry picking grounds. So actually, they don't want to disturb it. But how can they do that and still earn money and so on? So I think the only way forward is to just sit down and talk and get their perspectives and listen to their perspective and try to get them to listen to your perspective. I mean, that's the only way forward. It's communication.
Thank you. So I take one very last and hope short question there. A mic here, please.
Thank you. Teppo Hujala from the Germany Forest Research Institute in Rhineland-Palatinate. It's also a question for this. On the one hand, we saw that it's very important to see the scale of the water balance. On the other hand, is what we are concerned is the ecosystem services. And Lars, you showed us some nice pictures, but I think it's also very important to have a quantification of the water balance. Even if you are communicating, going into the communication, do you have a really hard data in communicating to the people and also to the foresters and so on? What happens with human impacts? It's not only machinery, it's also forest roads, it's also drainage ditches and a lot of things. Are there existing real hard data?
Thank you. So who wants to quickly answer that? Because we have half a minute to answer.
Okay, actually I can start. First of all, I just had 10 minutes to talk, so I could fill the whole day with talks.
This is why.
And actually there is hard data. And if you, the final slide was just a selection of papers for the last 2-3 years, I think. So the data is there, but just it's also a way to communicate your data. I mean, showing a graph for a forest machine operators doesn't tell him anything. It's better to tell it in other words. If you do this, this will happen. And don't do that, because then you can't go out fishing there in that river. You know, so it's...
Thank you. So now we are going to swap. First, I will ask you a big applause for these fantastic panelists we had. Thank you again. Thank you. And stay there, because now I'm going to call all the flash talks to come here, please. And we have quite a few. So. It's great. That's, you know, like. So please come, take a seat. Oh, sorry. So we have everybody, I think, because we have two that will be online, right? Okay, great. So we are going to start with our first flash talk, and it's going to be challenging because we have quite a few. So we start with Jamie Nettles. Thank you for being with us. So Jamie is at the Southern Environmental Research Management Institute in the United States. So I let you flash talk begin.
Thank you. First of all, I'd like to acknowledge my co-author, Brent Hawks. Some of the work that I'm going to present, he did to finish his dissertation at Virginia Tech under Dr. Mike Austin. It's kind of intermingled. So Weyerhaeuser is a large US landowner, and I've loved all the questions about stakeholders, about implementation and execution, because that really is why I wanted to show this example of what we were doing. We are a producer of dimensional lumber, of softwood lumber, and we're also certified under the Sustainable Forestry Initiative. If you're not familiar with it, it's a North American standard, and there are about 150 hectares that are certified under SFI with various sister groups. So there's a new indicator under this performance measure 3.2 that is under water resources. It's water quantity. And as you've heard all the research as a scientist, we know all these, we've heard, we know a lot, we just need to execute it. And also the things that we do not understand about, you know, the air sheds and the long-term fade and the scale issues involved in water. So as someone who is in the middle and taking research and working in research, but also translating this into on-the-ground indicators, this was really interesting to me. This was open for public comment, and I was gratified to see that the public comments for this indicator had a lot of the same questions that we all would. What is the baseline? Are we talking about overall water balance? And so in the end, it's more instead of yield, it's about water regulation. That if we look at these two things, it talks about training and then also about your on the ground execution for maintaining this natural range of variations. So this, again, this is year one of this indicator. So we're looking at this and saying, how do we take these things and translate it into on the ground action? In choosing this topic, one thing that I wanted to do was kind of illustrate the connections of the things we're talking about, but also in something, this is, like I mentioned, was early execution, but also highlight the importance of including private landowners in research and being here. There are not a lot of us here. I know that Lars has experience with working with private landowners. It's really critical to have this viewpoint when it comes down to the action that helps protect water resources. So the guidance suggestions from SFI, you can see it on the left. These are the guidance road trails development, harvest, and reforestation areas. So as we look at how do we implement these practices, the first thing we did was how do we take these things that they want to protect and put these into positive action steps. In the performance measure, one of the things was mentioned was best management practices. And in the Southeastern United States, that is what we use to guide our actions. And so on the right hand, this implementation of best management practices, you can see the bullets there. The BMP implementation is high. It's over 90% in the Southeastern US, whether it is regulatory, semi-regulatory, or voluntary, they're all implemented at a high rate, mainly because of certification and also license to operate. And like Lars said, there's a hunger out there to do what's correct. The other interesting thing that this addresses, though, is the variation from one place to another, that these all are different. And we get the question a lot, why can't you come up with uniform standards? But it is important to recognize variability from site to site. So in looking at BMP implementation rates, the next question we had was, where do we focus first? Is we're looking to improve water quantity. What is the first thing we do to improve forest regulation? Of all the things that we know about the forest, what is being done well in the Southeast and where does it need to improve? So going from left to right, you can see that on the right-hand side are the things that we think about as being more important for forest regulation. Do you have good infiltration? Is site protection maintained? Do you have an appropriate amount of buffers? You know, you have leave areas as well. And so the overall kind of forest management, that's done fairly well. Harvest areas would be planting on the contour, other site measures that protect infiltration. Skid trails are overall, this is more of a water quality issue, that it is by far the least implemented. In mountainous areas, it has the most direct effect of water quality, and this is across all landowners. Where we've discovered our weakness is in stream crossings, and this is across all landowners, by improving our ability to manage stream crossings, especially under climate change, where we have more intense storms occurring with less predictability, then by improving those, that's the first step we're going to take to protect water quality. So I appreciate everyone who goes forward. I want to just say, Lars was quoted already, but to say we know a lot of things. Are we going around in circles? Maybe so, but I like to think it's an upward spiral and not just a circle. Thank you.
Thank you for this big applause. It's challenging, this 5 minutes. So we're going to our second speaker is Theodora, Professor Theodora Asiamah is by Zoom. It's okay?
Yes, hello. Please, can you hear me?
No, we cannot see you. Oh,
I'm trying to show my video. Unfortunately,
yeah, your presentation is coming. Perfect. It's here.
So that's my picture.
Go ahead.
So good afternoon. I'm Theodora. I want to pick a pointer. Yes. So the topic is changes in ecosystem services in riparian forests amidst climate change, a case of the Densuano River Basin in Ghana. So ecosystem services of riparian forests have been a source of livelihood opportunities. The food provision components of the water body and the forest face a potential threat with climate change. So the study area is the Densuano River Basin, and it's a typical riparian forest which provides such benefits. So we see the map of the Densuano River Basin. This is the upstream, the blue, the green is the midstream, and then the pink is the downstream. So this is where the Densuano River Basin is located in Ghana, at the southern part in the eastern region. And when you look at the West African map, this is where Ghana is located. So we are looking at changes in the ecosystem functions of the Densuano River catchment over a period of 30 years. And we also established the underlying causes of these changes. We use social ecological approach in addition to geospatial technology, where we use Landsat satellite images. So the social ecological approach, we interviewed 450 respondents living in the catchment. So our findings, looking at the changes in land use, we found out, so the blue is for the status as of 1991, and the orange is the current status. So we found out that there's a decline in the land use for forest purposes. We can see above 30% as of 1991, and currently is less than 5%. So these are the responses from our respondents, the perceptions of our respondents as they recall as of 1991 and currently. And we also see a decline in the land use for mixed arable and agricultural purposes. It's also declined significantly. And when we look at the built area, there's an increase. So there's an increase in the land use for commercial buildings and human settlement buildings. So that has increased. So we looked at our satellite images, and it also validates the findings from the survey. The green is for the forest section or the forest land. So we can see that as of 1991, we have the whole area, the upstream portion being forest, and even the middle section also being forest, interspersed with the mixed arable crops. And even when you come to the downstream, you see some forest sections also downstream. This is 1991. But when we look at the status now, currently, we don't see any forest sections downstream. And we see the mixed arable crop taking over the forest. So we see a decline in forest land when we compare 1991 to current dispensation. And looking at the red, which is the built-up areas, as of 1991, we see the built-up areas relegated to the downstream section. We don't have much midstream, and we have a few sparse upstream. But when we look at the situation now, we see the built-up areas growing, taking over where we used to have forest downstream, and it's even growing to the midstream, and it's becoming more prominent. So this actually validates the findings from the survey. So we really found out that there's a decline in forest land, and there's an increase in built-up land. So we also try to find out if there's any association in the use of the ecosystem services vis-a-vis the various segments of the river basin, the upstream, the midstream, and then the downstream. So we found out that there's significant difference in the use of the land in all the three segments previously and currently. Interestingly, we found out that there's no significant difference in the use of the land for built-up purposes. So all the various streams, they use the land for built-up purposes equally. And interestingly, when it comes to the use of the water body for domestic purposes, previously, there was no significant difference in the use of the water for domestic purposes, but currently there's a significant difference. So what it tells us is that the relevance of the water body for domestic purpose previously was the same, but now there are differences in the relevance across the various segments. So in concluding, we are saying that our finding is saying that there's an increase in built-up areas at the expense of forest and farmlands, and there's also a decline in forest lands and farmlands. We recommend public education on the integration of urban forestry in town planning. We also recommend the Forestry Commission of Ghana in collaboration with the district assemblies to enforce the buffer zone policy to protect the river basin. Thank you very much for your audience.
Thank you, Professor Asiamah. She's with us from Ghana. Applause her. Thank you so much. So now we pass to our third talk, which is from Antonio del Campo, from the Technical University of Valencia, Spain. So the floor is yours. Oh, so sorry. We have a logistic issue here.
Okay. Yeah. Thank you, Sandra. Thank you, Adam. Well, thank you all people here, either here or at home. for letting me to present this study. I'm going to talk about thinning and hydrology. And this is a study which has already been published in this special issue that Sandra mentioned and Ada mentioned. So in particular, I'm presenting a meta-analysis, so a global synthesis on the effects of thinning on the hydrological processes, and then the implications for forest management. So why this topic? First, because, well, we know about generalities, about the effect of forest management on the different hydrological processes, but it is long known from the 60s, from the earlier forest hydrologists, that this is quite unpredictable and very variable, the effects of forest treatment on the different hydrological processes. Also because of the role of thinning, not just for water issues, but for many other issues related to adaptive silviculture and to adapt our forest to climate change. So to do that, we selected the meta-analysis as a powerful tool to integrate individual studies. So we followed the different steps of the meta-analysis, formulating questions, doing a systematic review, then deciding if a paper can be suitable or not for the meta-analysis, and then for those which were suitable, extracting and selecting the data, the study level effect size, the study level data. And then performing the meta-analysis and then doing the evaluation of the performance. There are two important outcomes when doing a meta-analysis: the effect size and the impact of the moderators. So the effect size can have different variability. So there is a variability inherent to the effect size, and then the moderators is to explain are the predictors that can shed sunlight onto this variability. So we found around 250 studies. Not all of them were suitable for the meta-analysis, only about 144. And then the remaining 100 were suitable just for a narrative meta-analysis, for a narrative review. Not all the hydrological processes could be meta-analyzed. I'm just going to refer here to those that were meta-analyzed. We use the metaphor package in R. And the effect size was measured by the ratio of means, so the control over the thinning treatment. So we had to select studies with those plots or stands, one control and one thinning. As moderators, technical moderators such as the intensity of thinning or years elapsed since thinning, and also climatic variables and this kind of moderators. The different biomes were more or less gathered in this meta-analysis. Some of them are more deficient in terms of sample size, but at the end, we could perform the meta-analysis. So the hydrological processes that we finally meta-analyzed were the stem flow, the through-fall or net precipitation. We had to join both. Soil moisture, total evapotranspiration, stand transpiration, and individual tree water use. So here you see the effects for the overall effect, also the size effect. And what we found were very significant differences in all of the hydrological processes, but in total evapotranspiration. In particular, stem flow and stand transpiration were higher in the controls. So there was more stem flow and more stand transpiration when not thinning the forest. And then for the remaining of the hydrological processes, through-fall, net precipitation, soil moisture, and tree water use, the effect was higher, or the amount was higher in the thinning. Regarding the moderators, the variability of the moderators, how the moderator explained the variability found across the globe, we found that thinning intensity was constant for the different hydrological processes. So removing about 50% of the basal area or stand density is needed in order to enhance the effect, the favorable effect of, or the positive effect of the thinning on the different hydrological processes. And also we found that the time lapse is quite short between 5 and around 5 years. For the categorical moderators, yeah, this is the final one. Sorry. So we could identify the differences for the different categories of climate, growing season, year. So you have the open access paper to go in detail. And then concluding what I'm not going to provide you numerical. The important point is that now we have a baseline. Now we have a reference for a global reference for the effects of thinning on the main hydrological processes. And very important for those of you producing paper, producing literature, to report on eco-hydrologically meaningful units. So this is very important when trying to meta-analyze, not just reporting average, standard deviation and sample size, but also the units so they can be directly used. Thank you very much.
Thank you, Antonio. Sorry, it's quite challenging in 5 minutes. So just to, I'm going to invite Teppo Hujala to the stage. He's from University of Eastern Finland. So you have a strict 5 minutes, but I know Finnish are very good this time. Count on you.
All right, hello everybody. I bring you greetings from Waterlands project, which is part of which is part of European Union's Horizon 2020 program's Green Deal call, a 5-year project which is now in its the second part of the first year. And here is the map of the partner countries. And what is important for this flash talk is the dark blue parts, which might be not so easily visible, but what is relevant is that we have 15 knowledge sites of waterlands and wetlands restoration from 13 countries from different parts of the Europe, north to south, west to east. And yeah, this is really a quite ambitious project that has the overall aim of upscaling successful and impactful restoration of wetlands and peatlands across the different contexts and ecological and climatic regions of Europe. The aim of this particular flash talk is to shed a little bit light on the different key success factors or success factor types of these showcases, the knowledge sites that we have in our projects. So what I did for this particular purpose is that I took the publicly available information about these forested peatland sites, ditched peatland sites, and that were recognized to be part of the project as these kind of successful showcases. And I did a qualitative categorization analysis on these different success factor types. What I did learn comes here together with conclusions, of course. So one success factor type is that there are some ecological features, uniqueness, something relating to the high ecological value. That's quite natural. The other one is the spatial features. So there are, in many cases, some really important connectivity, important kind of a scale, kind of a size of the site, for example. Then we have impactful policies in place. Typically, they are long-lasting policies. They could be international policies, fostering this international knowledge exchange, and also providing funding. And then we have a very important factor of success, the actors. Usually they could be kind of communities, non-profits, policy actors, business actors, whoever who are kind of clicking together. The actor networks and actor organizations are there, committed, motivated, and ready to work for it. Then we have the factor that is quite important, and I would say that a little bit surprising to me, but that is there. That is the cultural success factor type. That means that there are some culturally important features, historical cultural features in the site, in the community, in the region, that also kind of stays in the memory of people and fosters the access, let's say, acceptability of the restoration efforts. What we can learn through all of this is, of course, the first concluding point is not surprising. We have heard it already a few times today. No silver bullet to fit all places, no one-size-fits-all solutions. But we do learn here with these examples of the waterlands projects, knowledge sites, that there are different mixes of these success factor types, and they are kind of evolving contextually in each case, although we cannot fully orchestrate them, but we can still perhaps learn something and build our subsequent further analysis on the knowledge of the different types of success factors. With that, I conclude my talk. Thank you.
Thank you very much. Keep the time. So now we have Eva Verena Müller on the Zoom. Okay, so we welcome Eva from the Research Institute of Forest Ecology and Forestry in Germany. Hi, Eva. So hello. You have a strict 5 minutes. Welcome.
Yes, I'm just sharing my screen with you. And here is the documentation. Okay.
If you can put full screen.
Yes, sure. All right. Here we go.
Perfect. Thank you.
Hello, everyone. I'm very glad to have the opportunity to give you a quick introduction to my dissertation project with the topic analysis of forest-specific ecosystem services with regard to water balance components, runoff, and groundwater recharge in the forest. My study aimed on the evaluation of water-related regulative and provisioning ES using hydrological modeling, targeting the runoff regime and quantitative new groundwater formation in the Palatinate Biosphere Reserve in southwestern Germany, following a holistic approach which is suitable to describe how the ecological intermediate components are linked to service outputs and how sensitive these outputs are to anthropogenic pressures. The catchment area is a diverse rocky red sandstone landscape with close to 80% proportion of temperate forest. As possible loss factors for ES, climate change, soil compaction from infrastructure and driving with heavy machinery, as well as bare fallen areas with lacking ground cover were identified as stressors, and SWAP Plus was chosen for the hydrological modeling. For assessing the impact of climate change on the water balance components, this baseline period was chosen. Future projections were simulated representing the middle and the end of the century. For both RCP scenarios, corridors for possible developments were built based on maximum and minimum values, and the respective water balance components were compared to the baseline period and the recent development. For assessing the impact of soil compaction, 2 models were built with the soil properties adjusted for the forest road system and skid trails plus preloaded areas. The parameters bulk density and the model internal SCS curve number were adjusted according to driving test data, and the respective water balance components were compared with the uncompacted models. For assessing the impact of undeveloped canopy cover on rejuvenated stocks, 2 artificial models were built with differing plant parameterizations, modified for mature and juvenile stocking types. The scenarios were tested for plausibility. The respective water balance components were then compared between the models and with contrasting climatic conditions in order to identify hydrological controlling factors. Generally, the model results indicated favorable conditions for infiltration and water retention due to the geology and of the coarse textured red sandstone and the forest as land cover. Surface runoff was found mitigated and seepage and new groundwater formation promoted, but also falling trends since the year 2000 were shown for all relevant water balance components, and a short circuit drain reaction was identified to respond with higher peaks of surface runoff and stream flow after elevated precipitation amounts. So the indicators were found suitable for hydrological modeling. The interconnected functions and processes showed a sensitive character to changes, and overall the model results indicated good conditions for the regulative and provisioning ecosystem services in the catchment area. Furthermore, the model setup was shown sensitive to the addressed stressors, but functional losses from changes to the system. The climate scenarios revealed a decreasing trend for precipitation and correlating components such as percolation, groundwater recharge, and surface runoff for the middle of the century, and increasing trends by the very end. Both timelines showed altered precipitation patterns with more frequent heavy storm events and more frequent drought periods with an exhausted soil water storage throughout the vegetation period, a constant increase in atmospheric evaporative demand and extended vegetation period, so that consequently, the period for soil water and groundwater replenishment was found shortened. By the end of the century, an accelerated change in climatic conditions was simulated with more frequent pronounced peaks in surface runoff and the stream flow hydrograph. Regarding soil compaction from infrastructure, the pathway system contributed to a rise in surface runoff on catchment level of 36%, 242% in peaks after elevated precipitation events, and 12% in stream flow with 110% in peaks. Due to the line structure of the road network, the effect on groundwater recharge was limited to 2% loss on catchment level. For skid trails, a clear correlation with soil type was found on stand level. When sand-dominated soils showed overall negligible impacts, increased surface runoff and inhibited infiltration were found the most pronounced, with the highest loss in hydrological conductive macro and mesopores.
Sorry, Eva, you have half a minute. If you can wrap it up, thank you.
Yes, juvenile stocks were, yeah, okay, so there is, controlling factors, precipitation amounts and evaporative demand for the rejuvenated stocks were identified. The higher the evaporative demand, the scarcer the water inputs to the system, and the less developed the canopy cover, the more pronounced the hydrological differences between the stocking types were. And the results showed allowed for specific recommendations for actions to improve the retention potential in the area, which are all related to this issue. So thank you very much for the attention, and please
Thank you, Eva, for being with us, and good luck with your finishing your dissertation. Thank you. Okay, so we pass to Mathias Neumann now. Thank you in this marathon that we are having. So Mathias from the University of Natural Resources and Life Science of Vienna, Austria. So you're local here. So Mathias, you have your 5 minutes now.
Thank you, Sandra. Thank you for the organizers for giving me the opportunity to speak here. Yes, it's my pleasure to show some results, some spotlight results of ongoing research of colleagues and myself. And I will give you some thoughts on tree water use and climate emerging trends and drivers. So I won't give you an introductory slide. I will just jump into some methods that I'm going to use in the next couple of minutes. Water use efficiency. Water use efficiency in this classical term is the ratio of photosynthesis, growth, and transpiration. We have measurements for that, for this central characteristic of ecosystems, and it's measured by sap flow measurements, these beautiful plug stores that we have out there, tree growth chambers. These technologies, they're only available for a couple decades, probably not more, and they're rather costly. So colleagues and I will think about something else, like some other source for information on water use efficiency. What we came up with is in the literature, there's a so-called intrinsic water use efficiency, which is, it looks similar to the first term I've showed you. It's a simulation rate divided by the stomatal conductance. The interesting thing about intrinsic water use efficiency is that it can be sourced from other sources, mainly carbon isotopes that are stored in tree rings. So this is something that is a very attractive source of information, because now we are not bound to this observational period, the last couple of decades, that we can really look back into time. So how does this work? Why use carbon isotopes for water use efficiency? Fun thing is plants discriminate. So how does this work? Carbon fixing rubisco, that's an enzyme, discriminates the big 13C molecule, which has one additional neutron compared to the normal 12C molecule. So rubisco prefers this slight, smaller 12C molecule as long as the stomatas are open. And this is highlighted by the left picture. So basically, as long as there's fresh CO2 coming into the stomatal cavity, plants are able to basically discriminate the big 13C and pick out the 12C. This is different when the stomatas are closed. Then basically the plant is forced to pick up this big 13C molecule, indicated by the more dark green cells on the right picture. And so now this, since carbon is stored in tree rings over photosynthesis, this ratio of 13C to 12C is actually stored in the tree rings. And this is something we can utilize because we can then actually use this to reconstruct whether the stomatas were closed or mostly closed or mostly open. And that's basically the idea of intrinsic water use efficiency. And we get a time series of that metric. So what did we do? We conducted a meta-analysis. Won't go into detail. It's a pretty large data set that we compiled from freely available observations. What is behind that? A large number of tree ring data on intrinsic water use efficiency. We then linked these data points to grid climate data, to CO2 concentration, and also nitrogen deposition. I will just show you a couple thoughts on that in a minute. A very central metric that we used is this aridity index. You've seen it in a couple other slides. And what is behind it? It's precipitation divided by evapotranspiration, which is a measure of water availability. And you get some idea of the coverage of our data. So just a couple results. What did we found? Intrinsic water use efficiency has been increasing over the last decade by a considerable amount, yeah. But this increase has been slowing in the last 50 years or so. Second key result that I want to share with you, there are nonlinear patterns, as you've seen in the top picture, between water use efficiency and CO2 concentration, but also between water use efficiency and aridity, which is indicated by the picture down there. So things are not that simple. There's no linear change in that metric. Aridity is actually the stronger driver than water use than CO2 concentration. Yeah, that's something that was a bit surprising. Yeah, when we repeated this analysis, looking into aridity and other factors. What was also surprising that nitrogen deposition is quite important for water use efficiency, not so much in the northern hemisphere, but in the southern hemisphere. If you're interested in that, I have to refer you to the paper. So then this made me thinking, and I'm already behind time, so I will quickly go through that. What does this mean? If water use efficiency increases, this can mean a couple things, and I use these balloons for that. It can either mean that we have more water use and even more photosynthesis. It can also mean that we have the same water use or more photosynthesis, or the other way around with water use. And right now, I'm interested to understand which case are we having. And this is subject of further research. And I just leave you with my thoughts for next steps.
Thank you. Thank you, Mathias, so much. Sorry about cutting you guys. It's great stuff, but the idea was to do this marathon and just provide the key ideas of the work and not the whole development of the work. Anyway, last but not least, John Stanturf, so Dr. John Stanturf is from Estonian University of Life Science, and also from InfoSilva and Delmar, so you have two hats there. So welcome for our last presentation.
Thank you, Sandra.
This panel.
Okay, so I'm going to talk about the role of hydrological research in a very different kind of climate than we've mostly heard about so far. This is in the semi-arid and arid areas of Central Asia, specifically in the countries of Kyrgyzstan and Uzbekistan, and talking about the role of mountain forests in these areas. The rivers are the mountains are the water towers of Central Asia. They flow into the rivers. I guess I got that slide wrong. But there's a picture of the major rivers coming out of Kyrgyzstan, Tajikistan, and Uzbekistan, flowing down into the lowlands. And you've probably heard about the other end of the rivers and the environmental disaster of the dewatering of the Aral Sea. Well, this is at the upper end of the watershed where the water originates, and it's also under a great deal of pressure. I push, but it doesn't go. Ah, okay. Still not going. Okay, I'll use the mouse. So some of the threats that are there are overgrazing, fire, climate change, drought, and the things that happen are accelerated erosion, and it is not just the movement, but also sedimentation in the rivers, and resulting in a lot of flooding in the peak flow times, and also very devastating mud flows. So mass movements of material into the water system and flowing downstream has great impact on infrastructure and kills people in this area. So we have this project that's just getting started there. Our objective really is part of the Resilient Future Forest Laboratory that you may have heard about yesterday. My colleague Pelle Madsen talked about it in the restoration and degradation session. This is the modeling portion of that work. RFFL is an international network of research demonstration plots and locations in different areas, trying to illustrate for the public and for scientists and decision makers comparisons between business as usual and innovative treatments, innovation being defined in the local context. It's a vehicle for science practice, science society interactions, and hopefully it's a foundation for transforming landscapes and land use under future and novel climate conditions. So our modeling approach then in support of the on-the-ground work, because this is not only a water limited area, but it's also a data limited area, is very top down. We're using climate modeling, using the WRF, the Water Research and Forecasting model. It's a very higher resolution than the global climate models. And for the hydrological modeling, you've already heard about SWAT, the soil water assessment tool for looking at hydrology, and not just water flow, but some of the other parameters like sedimentation in systems. Our initial focus is on the Aktash Basin in Uzbekistan, because there we have what we would consider a natural experiment. Make sure I'm looking at it from your side. On the left side is an afforestation, a basin that was afforested back beginning in Tsarist times. So some of the stands there are approaching 100 years old. It's mostly broadleaf species, but there's also conifers mixed in there. This was a afforestation program that took place over 20 or 30 years. In comparison, on the right is the nearby basin that's still subject to overgrazing and is basically pretty devoid of vegetation. Our intent is to model the differences in hydrology between those two using, at the moment, weather data from CMIP, the Collective Model Intercomparison Project for weather data, as we get the WRF model spun up to look at future climate. And hopefully we'll be able to present some of these findings to decision makers and especially to the local people, to the herders, to get them to understand that it's important to afforest this area to protect downstream, but as also the local communities from the devastating floods and mud flows that occur. Thank you.
Thank you, John. Thank you for this great talk. Keeping the time as well. So I'm afraid we already took 10 minutes of the general program. So we need to end this session here. It was great talks. So thank you again. I'm going to ask you please, a big applause for all this difficult exercise of the
of the flash docs, and I apologize for being a bit mean with the time, but that was my job. But great, thank you again for all this great work. And then we continue. And thank you, Adam. Again, a big applause to Adam for organizing this session.
Thank you, Sandra, for your excellent job.
Thank you. So thank you all. I'm so sorry to all the organizers for this overloaded time, but it was great stuff. Thank you.